welcome. This is a presentation about space exploration, and we are going to discuss how space is explored. Now, in order to start this, I figured it'd be best to give some historical background to this because it hasn't exactly been happening for a very long time, so we might as well start where it all started. Space exploration began in Germany during World War II. A fellow by the name of Wernher von Braun, a Nazi scientist, developed the first V-2 rocket. That V-2 rocket became the first thing to enter space, the first man-made object to enter space, in October of 1942. After the war, the United States continued using the V-2 with the German scientists who were captured to aid American space exploration. And, basically after the war, the Soviets and the United States, who conquered Nazi Germany, got a bunch of scientists just to, well, mainly for military purposes in case the war broke out between the Soviets and the United States, but also for, exploration of sorts. In October 1957, the Soviets launched Sputnik 1, the first unmanned space vehicle to orbit the Earth. And, basically, this was not a complex mechanism. It was basically just something that could orbit and send beeps as to analyze the orbit. And it did so, and eventually, actually, upon re-entering Earth and leaving its orbit, it actually burned up, and yeah, it was never used again. Just within 4 years of that, and this is pretty impressive, Soviets launched Vostok 1, and it sent Yuri Gagarin into space in April 2nd, 1961. And this was a very impressive feat, and this really humiliated the United States in general. And it was done, of course, by the Soviets. Now, as to how we send things to space, or, well, let's just start with how they did it. The basic method of launching any vehicle into space is the job of a rocket booster, or launch vehicle. Both the United States and the Soviet Union had their own versions of it during the space race, and let's analyze those two. Oh, and once both countries began to race towards the moon, the rocket design was in need of an upgrade. Like, it really needed to be more powerful in order to house, or at least carry, something that can go all the way to the moon. The Soviets designed the N-1 rocket that failed miserably. This information wasn't published until 1991, the breakdown of the Soviets. That's kind of how the Soviets were. They only published what they were successful at. And yeah, after Vostok 1, they didn't really keep up with America. And the N-1 rocket design was underfunded and under-tested, and basically the first try failed. The second try failed so badly that it literally went up and then fell back down and exploded, causing one of the largest artificial non-nuclear explosions. Meanwhile, the Americans have the Saturn V, or 5, I suppose, if you like Roman numerals, which served as the launch vehicle for a lot of different space missions, but mainly all the Apollo missions. Speaking of Apollo missions, let's analyze just one of these Saturn V, or Saturn V is fine, by basically assessing them. The Saturn V that launched Apollo 11, this is a pretty significant Apollo that we're going to go into in the next slide, for example, consisted of 3 sections. At the very top sat the instrumental panel and control system, which automatically guided the sequence of ignitions of the 3 sections below it, and this is like the brain of the system, or the motherboard of the computer, I suppose. And now let's go into the sections. The first section, the SIC, had 5 rocket engines that used liquid oxygen kerosene as fuel. These engines could generate 7.5 million pounds of thrust, with which it could propel the spacecraft at 2,752 meters per second. Once that speed was achieved, the engines shut off, and the explosive bolts connecting the section to the rest of the rocket detonated. Section 1 then safely jettisoned into the Atlantic Ocean. So basically, once it does a job, it gets separated from the main vehicle, and, well, it has to land in a safe place, obviously, so why not the Atlantic Ocean? The S2, the second section, has the same purpose of putting the Apollo spacecraft into the Earth's orbit. However, it was the third section, the SIVB, that accomplished the task. The third section had a single rocket engine that was to be used twice, once to put the vehicle into orbit and the second time to leave it. Once the spacecraft achieved proper alignment after a few rotations around the Earth, the engine would reignite, guiding the Apollo spacecraft into a lunar trajectory. So basically, it orbited over and over until it could get on the right path to be fired again on a direct path to the moon. And yeah. Speaking of Apollo 11, Apollo 11 was the first vehicle or spacecraft that landed men on space, and this was an even bigger achievement than Vostok 1, basically for the fact that, well, the moon is really, really far away from us. And Apollo 11 achieved that, and further Apollo missions also reinforced the knowledge people know about the moon. And, well, this is basically the first time we have sent an astronaut to another object in space, and pretty much the only time, unless we're actually planning the Mars mission anytime soon. And this happened in July 16, 1969, and it sent astronauts Neil Armstrong and Buzz Aldrin to the moon. Michael Collins, the third crew member, was basically orbiting the moon for the trip back, so he never actually got to go on the moon. And, of course, it was done by the United States of America. I failed to mention that, sorry. Now, let's discuss what we explore space with. There are many types of spacecrafts with which we explore the universe. The one that we just mentioned are called manned spacecrafts, like the Apollo 11, and they are designed to carry astronauts into space. Generally, they consist of two modules: the re-entry module, the module that then returns to Earth, so that's where like the crew is, and the service module that contains propulsion, power supply, and life support, which pretty much all get separated away once they have done their job. Another form is the flyby spacecraft that follows a continuous trajectory past what it's observing, but it doesn't really go into the orbit of what it's observing, so it just like flies by. That's the whole flyby name to it. Examples of that include Voyagers 1 and 2 and Pioneers 10 and 11. On the other hand, we have the orbiter spacecraft, which is designed to go into orbit of a planet or moon. And this spacecraft has the hard task of decelerating at the right time in order to enter the planet's orbit. Additionally, it has to endure the thermal variation that results from circling the planet. And what I mean by that is basically, well, when you circle it, there will be times when you're going to go into the planet's shadow. That means away from the sun, and that causes all kinds of problems. I mean, if the spacecraft is charged by solar panels, it better have a power storage as well, otherwise every time it goes behind the shadow, it pretty much dies away or dies out. Other spacecrafts include a surface rover, which is a small vehicle that is steered from Earth and is deployed to the surface of other planets or moons to take images and analyze the soil. The most famous of these are Mars rovers, although we have rovers on the Moon and Mercury and some other planets. But yeah, the most famous of these are the Sojourner and Curiosity. Right now, the most powerful one is Curiosity. And yeah, that's about it. And of course, we have atmospheric probes and balloon packages that are used to study the gaseous atmosphere and wind circulation patterns of different planets. They're basically just parachuted down to the surface of planets. The one you see in the picture is of Earth, but we do use these for other planets and moons as well. And of course, the peak of our exploration and what we can explore the furthest with is space telescopes. And the most famous of these is the Hubble Space Telescope, and these are just some of the images that it has the potential to take. The M51 Spiral Galaxy, and a whole bunch of nebulas, which includes the Carina Nebula, the Butterfly Nebula, and the Orion Nebula. Quite pretty. Next up, let's analyze this thing. Or rather, let's analyze the Hubble Space Telescope, because it's a good example, and it's the most famous space telescope. Like all telescopes, it is a form of a tube that is open at one end to let light in. This light undergoes several reflections to come to a focus within the telescope. This is basically how any telescope works. And these aren't just any mirrors, they're made of glass, and now stay with me, this does sound basic, but anyways, they're coated with pure aluminium, 3 millionth of an inch thick, and magnesium fluoride, 1 millionth of an inch thick. And they can they can reflect anything starting from the infrared all the way to the ultraviolet. And that really helps out. The HST detects all kinds of light and then turns them into digital signals that are relayed back to Earth. Other than the main WFPC2 camera, the HTS also has spectrometers and spectrographs that act as additional cameras and prisms with which the telescope deciphers the incoming light, analyzes the intensity of different wavelengths. The HST can even tell us the composition of faraway planets, stars, and even galaxies. And basically, just by analyzing the different lights, it can send digital signals back to Earth, and those digital signals are what allowed us to make the images that we have seen in the previous slide. And yeah, this is the peak of our exploration at the current, and yeah, to infinity and beyond. Here are the references. You may check them in the actual Keynote file, in case you're wondering. And here are the picture sources, since, I did use a lot of pictures. And yeah, that's about it. Thank you for tuning in, or I guess watching, and yeah, have a nice day.